Hello everyone, this is Astarag, and today I wanted to demonstrate one of the project that I'm working on. Is called as Agent Shaper. Agent Shaper is a MCP server which will convert your PyTorch code into einsum and einops. Einsum and einops are symbolic representation of tensor manipulation. Here you can name each dimension, and based on your transformation you can name those dimensions, and this is supposed to help with readability. So I built this MCP server which will help me to convert any arbitrary PyTorch code into einsum and einops, do testing, and ensure that the code is correct. Under the hood, Agent Shaper uses context from ShapeProp or TorchFX, which is offered by the PyTorch team, and ShapeProp is does tracing of shapes in tensors in your transform in your nn dot module or any function. So under the hood, it uses this ShapeProp to go across a torch function, torch tensor manipulations, so that it can ground its einsum conversion with ground truth data from this library. So to demonstrate this, I went ahead and added the Agent Shaper MCP server to my Cloud Code MCP, and you can add it to your mcp.json like this, and then you can directly just ask your language model, Claude, or any other MCP client to convert a arbitrary code into einsum code. So I asked to convert the GPT-2 uh, PyTorch code that I took from an open source project and asked it to convert into Torch, einsum, and einops. So this is what it came up with. So this was the initial module. Uh, if you see here, like it's like transpose 1 comma 2, it's difficult to know what's the dimension 1 comma 2. Here also transpose 1 comma 2, and there is a split across this dimension, and there are no comments here. So this MCP server can convert the arbitrary PyTorch code into more readable. So here we have comments, and also when there are tensor manipulations, it uses einops rearrange, where you can see the dimension of each of those tensor axes. So this would be the batch size, sequence length, head dimension, and the embedding dimension, and how it is transforming those dimensions. And also the attention, for attention it's gonna convert it into uh, torch, einsum, and einops. And you can see here it names each and every dimension. Uh, it adds proper comments for each of those dimensions, whereas in the earlier code there were no comments, there were no shape transformations. But this code is more readable, and also it goes ahead and write test cases for each of those conversions. So this is the test case for let's say the causal attention that we are looking at earlier. It wrote a test case where it saved the earlier module, so it's a causal self attention. It stored the input quarks and the input and the output and the module, which was the previous snapshot before the conversion. And after conversion, it checks if your uh, input and output tensors are same or not. So this is like a grounded way of doing the work of converting any PyTorch code into Torch, einsum, and einops. So this is one of the example that I did for GPT-2. You can also like read through rest of the code, and it does a pretty good job of tracing the shapes, and then helping it helps the language model to write the einsum and einops code. So I also went ahead and did for other models, like let's say for llama. So this is the original llama code. If I just bring it here, so this is the original llama code. It's like torch view, expand, type as, forward. Like this is for me it always feels intimidating when I look at this code. But if it is like einsum, you can like see it's like so much better to read through, and also it adds comments. So if I go to the self attention module, it looked like this. um, view, yeah, it's kind of obscure transformations, but here you can see all the transformations with torch einops rearrange with comments attached. And even if you copy your uncommented code base or a PyTorch code base, you can do that with this MCP server. So this is much more readable as compared to this. And also, you out of the box you get support to do testing and ensure that your conversions are correct. And some other examples are, uh, so this example I took it from the RLHF codebook, where it's different alignment losses like DPO, SIMPO, ORPO. And I asked Claude using the agent shaper to convert it into einsum, and it came up with this. And this is also, I would, if I do for both of this, so if you look at this compute log probs, there's like a logs of max along dimension 1. There are no proper commenting here, but here is this on this side with the agent shaper MCP server, you get einsum, and you can know where you are reducing, on which dimension you are reducing. And yeah, like this is much more readable and faithful.